Hello, grade 12s. Today we are going to talk about probability and how that relates to something called odds. So far we've already discussed what the probability of an event and how that can be calculated, and it can be done so using that equation below, where the probability of an event is equal to the number of possible ways that are favorable, the number of ways that event can take place, divided by the total number of possible outcomes. Now, odds are another way to express that same information. Now, odds are often used a lot on the gambling scene, to be quite honest. So you might say if you're going to the horse track and you're going to gamble and bet on horses, oftentimes the values given to you about each of the horses are provided as odds. Now, there's two different ways that odds can be represented. We can represent those ratios as odds in favor. And what that looks like is odds in favor are the ratio of the probability that an event will occur to the probability that the event won't occur. Okay, so when we take a look at how we define odds in favor, how we represent or write down odds in favor, when we talk about ratios always have this colon in between. And there's a number on the left of the colon and a number on the right of the colon. Now, that colon for odds in favor, that number on the left of that colon represents the number of favorable outcomes, which when we take a look at our probability formula, that's our numerator. And that's where we can see this value coming out. So the number of favorable outcomes goes on the left. Now, along the right of that ratio for odds in favor is the number of non-favorable outcomes. When we take a look at our probability formula, that value is not actually there. It's not present. But we can easily figure it out because in our probability formula, our denominator is the total number of possible outcomes. So to define the total number of non-favorable outcomes, we can simply take that denominator and subtract the numerator, right? The total possible outcomes minus the number of favorable outcomes will equal the number of non-favorable outcomes. Now, that order is specific to odds in favor, but that order is reversed when we talk about odds against. So the odds against is the ratio of the probability that an event won't occur to the probability that the event will occur. So odds against is just the reverse order of odds in favor. So we'll notice in that kind of setup of the ratio, we have the exact same numbers separated by that exact same colon, but this time the numbers are in that reverse order. Now, it is assumed that if we're just asking about the odds, we assume they're talking about odds in favor. If we're talking about odds against, it will say what are the odds against. It will say that explicitly in a question type. Something to kind of point out is odds, just like probabilities, can be reduced. I know typically we don't represent we haven't reduced ratios or really used ratios a lot. But just like we do with fractions, if the top and the bottom are both divisible by some common factor, we can reduce it. Same idea with ratios. So if I had like 20/40 as a fraction, yeah, I could divide top and bottom by 20, and I get 1/2. Same idea if I have 20/40 as a ratio, I can divide both sides by 20 to get 1/2. So something to just keep in mind. All right, we're going to talk about today on how to convert between the two of those things, between odds and between probability. And again, hoping that we see the commonalities between our equations, between our setup for odds and our equation for probability. All right, let's take a look at this. So we're converting probability to odds first. So we're given the probability of randomly selecting a red marble from a bag containing many colored marbles is 3/22. Now remember, my probability formula is equal to the number of favorable events over the total number of possible solutions or options or outcomes. So in this case, if we're talking about probability of randomly selecting a red marble, the 3, that numerator, represents the number of red marbles. And the 22, that denominator, represents the total number of marbles in that bag. Now, if we know that information, we can use that information to help us identify how many marbles in that bag are not red. Well, if there's 22 total, 3 of them are red, that means 19 not red marbles exist in that bag. Now we can start looking at odds. Now the question here asks us, or the next two questions I should say, ask us about both odds in favor and odds against. So the first one saying, what are the odds that the marble is, what is the odds of the marble being red? Well, my odds in favor would be, okay, I'm looking at red to not red. And I can just replace those values with the numbers I already know. Well, I know there's 3 red marbles and there's 19 not red marbles, so my ratio is 3/19. If I wanted to represent this as odds against, that order is simply reversed. I'm talking about not red first and red second, meaning my order is swapped to give me 19/3. Really important thing about probability is that denominator does not show up in my odds. That number is not present. And that's probably the biggest mistake that I see, is that people look at probability and go, oh, 3/22? Well, the odds just must be 3/22 or 22/3. That's gotta be right. But that is not the case. That second part of the odds represents the difference between the denominator and the numerator. Okay, going through. The probability of the Winnipeg Jets win their game against the Edmonton Oilers is 8/12. What are the odds that the Jets win a game against the Oilers? Well, just talking about it, I know that the 8 represents wins. The 12 represents total, which means that difference, 12 minus 8, represents a not win. And you might say, well, what do you mean not win? Like, why can't you just say lose? Well, there's different ways they can not win. They can tie, they can lose. So something just kind of thinking about that difference represents the not favorable outcomes. So if I'm talking about the odds that they win, I'm looking for the ratio of wins to not wins, which I know. I know win is 8 and not win is 4. Now, reminder, we said that ratios could be reduced, and here I can see that both the 8 and the 4 are both divisible by 4. So I can also represent this as 2 to 1. That's the odds that the Jets win their game against the Oilers. All right. Next example here, the probability that it will snow tomorrow is 12%. What are the odds for it snowing tomorrow? And what are the odds against it snowing tomorrow? Okay, 12%. Something to talk about is this represents my probability as a percentage, but all of the probabilities that we've been talking about when converting to odds have been fractions. Now, what is that 12 out of when I talk about percent? That's really 12 out of 100. So when I take a look at representing my odds, I know for snow, I've got 12. The total, I've got 100. So for not snow, I have that difference. 100 minus 12, which is 88. Now I'm asked for two things here. I'm asked for the odds for, and I'm asked the odds against. So the odds for means that I want the ratio of snowing to not snowing, which means I have 12 to 88. Now I can reduce this, right? And just like fractions, if you don't reduce it by the largest common factor at first, that's okay, you can just keep on going. But if I wanted to reduce this, I can immediately see that they're both divisible by 4. So I can say that's 3 to 22. And 3 and 22 can't be reduced further, so lovely. This is my final answer here. When I'm talking about my odds against it snowing, that means I'm looking for the ratio of not snow to snow, which just means that I'm reversing those numbers. I've got 88 to 12, or I can represent that as 22 to 3. Okay, so we can go in one direction. We can convert probability to odds. The other direction is similar. We just have to go from converting odds to probability, remembering those same pieces. That the denominator doesn't appear in my probability, doesn't appear in my odds, and there has to be a little bit of work to get it there. So let's take a look at our first example of converting odds to probability. If the odds of a student athlete being randomly selected from a class of students is 17 to 13, let's talk about what each of those numbers represents. That 17 represents, well, the number of student athletes. Because we're talking about odds for. It doesn't say odds against, so we need to assume it's odds in favor. And that 17 coming first means that that's the number that represents my favorable outcomes. The 13, that second number, represents the number of not student athletes. What if I asked you about the total? Could you figure out what that total amount of students in the class is? Hopefully you go, yeah, well, if there's 17 student athletes and 13 not student athletes, that means I have a total of 17 plus 13, which is 30 students. And that 30 is important because when I'm talking about probabilities, that 30, that total possible outcomes, is my denominator. So in the following two questions, when it talks to me or asks me about the probability of selecting a student athlete or not selecting a student athlete, I know that both of those probabilities will be over 30, over the total. And the numerator will differ depending what I'm asking the probability for. So what's the probability of selecting a student athlete? Well, there's 17 of them out of that class of 30. Oops. So I have 17 over 30. And what's the probability of not selecting a student athlete? Well, there's 13 of them in a class of 30, so the probability is 13 over 30. Okay, similar questions. Oops. Different context. Can you try the next two on your own, please? Thank you. Okay, the odds that Mary will go to Tim Hortons for a coffee on any given day are 4 to 3. I'm just talking about it. So 4 means go for coffee. 3 means not go for coffee. Total is 7. Okay, just immediately interpreting those values. So what is the probability that Mary will not go to Tim Hortons for coffee tomorrow? Well, not going for coffee gives me a numerator of 3, and I put my total as my denominator, which is 7. And question B, what is the probability that Mary will go to Tim Hortons for coffee tomorrow? Well, we say 4 represents the going for coffee, and the 7 is the total, so I have 4/7. Next, the odds that a basketball player will make their free throw is 7 to 4. So that 7 represents make the free throw. Make free throw. That 4 represents not making the free throw. And the total is 7 plus 4, which is 11. So if I'm asking these questions, what is the probability that the basketball player will make their free throw? Well, the total number of favorable outcomes is 7 over the total, which is 11. And what is the probability that a basketball player will miss? Well, not make their free throw is 4 over the total, which is 11. So as we go through these and we're converting back and forth, we can go ahead and start by interpreting what I've got there based on the odds originally. And if I can interpret what those odds mean, then I can easily convert them into probabilities, like we've seen in the last 2 examples. Now, being honest here, when we talk about odds tend to come up more as like a follow-up question for probability. So oftentimes we might have a question where you have to find the probability that something happens, and that might be part A of the question. And then part B is represented as odds for that outcome or odds against that particular outcome. So we don't often have a lot of odds questions existing independently. Typically they're thrown on after a question, which means that if this is like a part B and we've got part A completely wrong, we have no idea what to do. We have no idea where to start. We're like totally out for lunch here. We're like, I have no idea what to do. We'll make up an answer for part A and then correctly represent that probability as odds in part B, right? Please note that whenever math is marked, it is not necessarily based on correctness if it is a follow-up question. It is based on correct follow-through given whatever answer you've provided in the previous question. So please know that if you don't know part A, but you would be able to do part B if it was an odds-based question, feel free to make up an answer for A and follow through correctly for B. Okay, last page. Now let's talk about analyzing data so that we can make a decision. So oftentimes, odds and probabilities are provided to us so that we can go ahead and have some sort of decision that we can make. Now, realistically, when we take a look at odds or we take a look at probabilities and we're trying to make a decision, maybe we're comparing two individuals. In this first example, we have the Jets coach needs to decide whether Wheeler or Little should go first in the shootout, and they want to choose, the player who has the best chance of scoring. Odds aren't very useful in comparing unless one of those numbers are identical, right? So if I'm looking at Wheeler and Little right here, they have different total number of, penalty shots or shootout shots that they've taken. So we can't really directly compare them and look at the odds provided or the data provided and be like, oh yeah, obviously so-and-so should go first. Now, quite honestly, probability as fractions, for similar reasons, aren't the most useful to compare either. As long as the denominators are different, it might be hard for us to directly compare. Now, when we take a look at making decisions, oftentimes we want to represent that information in a way that is really easily comparable. Now, that can be representing it as a probability, but specifically as a decimal, or representing the data as a probability as a percentage. Those tend to be the most useful ways to directly compare two sets of data so that we can make a decision for it. So, jumping in on that, let's look at this example. So a Jets game ended in a tie after a 5-minute overtime period. The winner will be decided by a shootout. The coach must decide whether Wheeler or Little should go first in the shootout. The coach would prefer to use his best player. Okay, now we have some data on Wheeler and we have some data on Little. So let's talk about Wheeler. And if I'm taking a look at this, I can easily say what his odds of scoring are. Odds of scoring. Well, that's the number of how many times he scored to how many times he didn't score. And I can see that the odds of him scoring are 10 to 17. Okay. And I could do the same thing for Little. I'm going to leave some room because we'll see that we can't directly compare these back to back. Once we compare the odds here, write down what the odds are. So the odds of Little scoring are 19 to 28. But we just don't look at that and go, oh yeah, I know who I should choose. Because the numbers are so different. But if I converted those to a probability, that can be a little bit more helpful. So the probability of scoring has that 10, but my denominator is the total. So 10 plus 17, which is 27. And I could do the same thing for Little. The probability of scoring is 19 over the total, which is 19 plus 28, which is 47. Now you might say, Miss T, that doesn't actually help. And I'd be like, yeah, you're right. I can't just look at those and automatically in my head really easily tell which one's bigger or has a higher chance of scoring. But if I converted that to a decimal, I plugged that into my calculator, I get that the probability for Wheeler is 0.37. And the probability for Little is about 0.40. And those are numbers I can directly compare. I know that Little's probability is higher than Wheeler's, which means that if I were the coach should choose Little because he has the higher probability of scoring. Okay. The coach should choose Little to shoot first. So this is an example of how we can use data to make a decision. We have one more example that we're going to take a look at as well. And that example is about flu season. So flu season's back. Studies show that 85% of the people who received a flu shot did not get sick. 37% of the people who did receive the flu shot did get sick. Determine the odds against getting sick if you are vaccinated. Okay, taking a look at things like this, those two percentages are not the same. Those two percentages, the first one, the 85, represents the number of people or the percentage of people who did not get sick, where the 37% represents the number of people who did get sick. So it's important that we take some time and really clearly read what's going on here, because we can't assume that the data values provided are the same. And if we're talking about, probabilities, or we're talking about something that helps people make a decision, depending on who's providing this information, they might try and provide it in a way that makes you want to go forward in a particular path, right? So if I was like a company and I wanted to make, influence you to make a certain decision, I'm not talking about vaccinations here, but maybe I'm talking about, purchasing a toy for a toddler, and how like a certain percentage of toddlers excelled after having this toy as a child. I don't know. But I might want to use that data and represent it in a way that seems like, oh wow, a lot of toddlers really excelled because of this toy that they had. You might want to represent the data in a way that seems beneficial to my purpose or my desires here. So data is not always represented in the same way for every single data point, so it's important to read what's going on here. So I want to determine the odds against getting sick if you are vaccinated. So first of all, I have odds against getting sick, which means I want to talk about not sick to sick, right? Odds against means that not sick goes first. And I want to talk about if I am vaccinated. So I need to look at the question and find the data point that talks about people who received the flu shot, which is the 85% value. Now, I'm taking a look at that 85, and the 85 represents people who took the flu shot but did not get sick. So that 85 goes with the not sick part of my ratio, which means sick is the remainder. So if 85 out of 100, the remaining is 15. So quite a bit of thought that has to go in here, not so much because the answer is really hard to get to, but more so that when we take a look at all of the information provided, it can be easy to look at this and go, oh my gosh, there's a lot of content here, and get it mixed up. Of course, I could also reduce this. So when I take a look at this, I can see that both of these are divisible by 5. And 5 goes into 85 17 times and goes into 15 3 times. All right, next question. Determine the odds against getting sick. So again, same order, not sick to sick, because I'm talking about odds against, if you were not vaccinated. So I'm looking for that data point, specifically this 37% of people who did not get the flu shot did get sick. Okay, so now I'm saying, okay, 37% of these people did get sick, so the 37 goes on the sick side of my odds, which means that remainder, 100 minus 37, which is 63, goes on that alternate side. When I take a look at this, I try to reduce if I can, but this is what I've got. Now, when I take a look at these odds, both of these odds represent information in the same order. And based on the statistics, should someone get the vaccination, why or why not? And this is against your opinions. This is against your own personal beliefs. We're only basing this decision based on the statistics provided in this question. Nothing more, nothing less. And when we take a look at this, the reason why this is kind of helpful in my odds, and I can compare them directly, don't have to go into probability, is because my total for both is out of 100. Right? 85 to 15, those two values add to 100. 63 to 37, those two values add to 100. So when I'm trying to decide, hey, should I get the vaccination, why or why not? I'm looking for the value that has the higher number of people that are not sick. And when I'm doing that, the not sick value that is higher occurs when I'm in this part here. And this is when I am vaccinated. Okay? And again, this is not personal opinions. This is not what I am necessarily trying to tell you to do. That's your own decision to make. But based on these stats provided in this question, we should be recommending that someone gets the vaccination because they have a smaller probability of getting sick afterwards. So let's write that. They should get vaccinated because they have a smaller chance of getting sick afterwards. All right, so that's how we can use odds and probability to make decisions. We also talked about converting between the two of them. And that's all of 6.2. There is some practice that follows. Please take a look at it. But otherwise, have yourself a wonderful rest of your day. Bye.